This is the second session of today's AI and Deep Learning program here at the AWS Loft in London. And hi if you're watching us on the stream as well. Hi. So in this second session, we're going to be talking a little bit about some of the higher level services that AWS provides to make access to AI and deep learning services simpler for developers that don't want to build their own neural networks and train their own models. So the focus for this particular session is Amazon Poly and Amazon Rekognition. My name's Ian. I'm in the technology evangelism team at AWS. And if you've got any follow-up about what you see during the talk, I'm going to show a few demos and also share a GitHub repo at the end. If you want any follow-up on that, just find me on Twitter at IanM with 4 M's, or you can reach me by email at IanM, Indigo Alpha November Mike, at Amazon.com. Okay, good stuff. Yeah. I thought I'd have one completely overblown transition in my deck before we get on to the more conservative things later. And that seemed quite appropriate for, neural networks. So Amazon AI, this is a suite of services that we announced at reInvent. That's our global customer event last year at the end of December. We announced 3 services in the portfolio. We also announced I guess you could sort of describe this in a neural network type way as a multi-layer strategy for helping developers be more productive with AI on AWS. And that is to focus on creating these high-level services that make it really simple for developers to add AI features to applications that they're building without having to know a whole lot about how those services work under the covers. So that's what we're doing at the top. And we have more of these services to come during 2017 as well. So expect to see more stuff which is similar to Poly, Lex, and Rekognition later this year. We're going to bring forward some more services which have similar sort of accessibility characteristics. Then we're also investing in platform components, and this is about making AWS more generally the best place to train and run deep learning neural network models. So this is really about integrating AWS components with frameworks. And some of the stuff we've done there, of course, is about our contributions to MXNet. But we've also gone further than that and created an Amazon Deep Learning Army. So that's an Amazon machine image to run on EC2 that includes not only MXNet, but also TensorFlow and a variety of other deep learning framework components that developers use to build these kinds of apps. If you want to know more about that, I'm going to give Julian a bit of a plug here. I'd really recommend finding Julian's Medium blog, okay, because he produces some really awesome content which covers how to get started with some of these platform components on AWS in more detail. It's not really for this talk. And then we've got the workshop at the end of the day where we're going to dive into a bit of that stuff as well. So we're making these engines really accessible via AWS. And of course, underneath all that, we've got things like the P2 instance family with its high performance GPUs, and I've got other platform components as well, like placement groups that make a really good infrastructure base upon which to run these kinds of applications, both to train and run predictive models. We're not really talking about that here. What we're talking about here, of course, is these more accessible services. And in the first section, we're going to focus on Poly. Later on, we'll talk a little bit more about Rekognition. And then I've got another session, I think at 1 today, where I'm going to show some stuff with conversational interfaces with Amazon Lex. So come along for that. There's actually a relationship between Amazon Lex, which is our service for chatbots, and Poly, and that is that Lex can generate audio output. So our chatbot service works for both text and speech. If you want to use Amazon Lex with voice, so with devices where you're going to play back the responses to these conversational interfaces that you're building, the speech generation is done using the Poly service, which kind of indicates what Poly is. It's a service for generating lifelike speech, okay? And we use a neural network substrate, which is invisible to you and abstracted from you, to continuously improve the accuracy of the rendering. So we're taking text or marked up input files, which we'll talk a little bit more about later, and we're providing an API endpoint where you can submit those text strings or marked up input files. We'll return back to that API request a rendered audio file, which is a spoken version of whatever you've asked us to generate. Okay, and that's a fully managed service which runs behind one of our AWS API endpoints. So if you're into security in the cloud, you might have heard of this concept of the shared security responsibility model that we use. If you are familiar with that, this service would fit into the abstracted services category. So authentication and authorization for access to the service, it's done using a service called AWS IAM, or Identity and Access Management, use credentials and IAM policies to create rights for users, or principals as we call them, to access the API endpoint, to submit text or SSML files to us, and to receive back rendered audio in the format that you specify. So you can exercise fine-grained control, actually, over how your applications, or rather the identities associated with your applications, can make use of this service. That means that you can embed it into things like applications that run in untrusted environments, like in the browser or on a mobile device, and do that in a way with granular access control. So you can use this service to embed speech in browser-based apps, or to embed speech within your own mobile applications that you're building. Broad voice support. This is wrong. We've actually got 48 voices now, so I should have updated that. We added a German female voice in the early part of the year after the initial launch. We have 24 different languages that we support, including some languages that you could describe as pretty niche. Not to disparage any Icelandic people, but there aren't many Icelandic speakers in the world. There's about 400,000 of them in total. We can speak Icelandic, so we added one to the global Icelandic speaker population, or two, in fact, so we've got a male and female voice when we launched the service. It's pretty cute. Low latency in real time, so it's responsive enough to use for interactive applications, but you can, of course, also use it in batch, in async mode. So if you want to voice a video or transcode a large block of text and keep that forever, you can do it. You could also use this service as part of a product engineering process. And we've got a customer called Duolingo that do that. They use Poly to create foreign language voices that they then use for their language tutoring service. So they asynchronously generate the voices, embed them in the courses that they're creating, and just do that once, which is a very cost-efficient way to do it. Could also use it as a mechanism for translating. Say if you're producing an IoT product which has voice components in it, and you want to launch that product in another market, well, you can create your foreign language speech using this service. It avoids the need to hire expensive translators, potentially expensive translators, for just a few phrases that you might want to translate. Maybe for an MVP, you could even use a machine translation service to create the text that you're going to then render and use in your foreign language product. So there's a lot of innovative ways that customers use the service. So, what does it sound like? You can't really do a presentation like this without audio, so I'll look up on the gallery and say, I hope that the guys up there have turned my audio up. Let me show you a few things. Just click this. Or rather, well, hang on, let's mirror my display. Rather than show you a few things, of course, it's play you a few things. All right. Mm-hmm. Sorry, let me just flick my screen around so that I can be in control of it at the same time as you can see it.
Today in London it's 25 degrees Celsius.
Okay, so one thing that you should have noticed there is we've got expansion. So if I've got a phrase which includes symbols or abbreviations which are rendered by the human voice in a different way to the way in which they appear on screen when I write them, the service is intelligent enough to notice that. Okay, and it's intelligent enough to render the language using the expansion. It works for things like US states. It works for quite a few contractions of this type, but you can also use the SSML markup to annotate the input that you're using and create your own custom expansions as well. This could be useful for things like periodic table elements where you might have HG in the text, but you really want Mercury when you read it out or render it. You can use a text preprocessor to insert the SSML tags automatically as part of a workflow for that kind of use case as well.
Today in London it's 25 degrees Celsius.
The other thing that we have good support for is accuracy. So And no matter how many times Polly says this, she never gets tired of saying it, which is also interesting.
She sells seashells by the seashore. The shells she sells are surely seashells. So if she sells shells on the seashore, I'm sure she sells seashore shells.
You know, it's the Australian female voice that's been used there rather than the English, British female voice. So we've got nuances of pronunciation for different parts of the English language in this way, in different dialects, regional accents or countrywide accents, let's say. We can also add semantic meaning to text. Now this requires markup. So what we've got here in the background is an SSML marked up file which includes the say as, interpret as number or say as, interpret as telephone tags, which changes the treatment of numbers that appear in the text. So let's just play
Don't
this demo.
say. Ian's number is 7,917,751,805. When you mean. Ian's number is 791-775-1805.
I discovered an undocumented feature, which is that if you zero pad the numbers, it automatically defaults to the telephone pronunciation, but it's undocumented, so I wouldn't recommend using that. I'd always recommend using the markup per the documentation in case that feature gets changed over time. So you can zero pad your numbers and force the telephone pronunciation. So we have the capability to support that kind of use case as well. And then we can also do customized pronunciation. So this is SSML markup that is focused on ensuring that words that are misrendered by the engine can be tweaked to produce the correct rendering. So let's just have a listen to these two different examples.
My son's name is Jay.
Which could be right, but actually...
My son's name is Jai.
So we've got SSML markup there, which amends the pronunciation of the speech as rendered. And we have flexibility to change or even create our own custom lexicons as well, which are custom pronunciation dictionaries that are scoped to our own AWS account. So if I knew that whenever I saw that phrase in one specific account, I wanted it to be pronounced a certain way, or maybe I wanted to make a custom pronunciation for a product name or for an abbreviation, then I could customize that in the lexicon. Okay, so there's a question here from Twitch, which is about data transfer. So the data that comes back from the API is audio data encoded using a specified format. So when I submit my API request, I'll specify MP3 or an alternative audio format, one of the supported alternative audio formats, and I'll receive back either a file, if I specify receive a file, or a stream, which I can then play dynamically from within my own code to play the audio straight out to an audio device. So you've got a couple of different options there. I hope that answers your question. Okay, so just quickly summarizing then, before I jump into the console and show you a few demos there. You've got this continuously improving model because we're using deep learning to underpin the service. So over time, the quality and accuracy of the pronunciations will continuously improve. It also means that we can add additional languages and additional voices. We have pretty deep functionality, which I'm going to show you on the console, a few more tricks and tips that you can use to further customize the way in which the pronunciation is managed. Very easy to use via the AWS API endpoint that we provide, and there's a programming model for that, and of course our SDKs support the service, robust, and there's actually quite a generous free tier as well with this service. So next thing I want to show you is a quick demo of console and command line use of the service. I'll just jump out of my slides. For service testing and setup, we provide a fully interactive console, so you can generate audio directly within the AWS console for testing purposes. This is, of course, a GUI that sits on top of our API, so when you're sending requests through this GUI, what's happening is the AWS console is communicating with the AWS API endpoint for the service using IAM credentials associated with your account. So at the back end, it's exactly the same as the process that would be used if you're writing your own custom front end using one of our SDKs. But you can essentially create your own API request documents by using the console.
Hi, my name is Kendra. I will read any text you type here.
And you can switch between voices using this console to experiment with them.
Hi, my name is Dustin. I will read any text you type here.
So we have children's voices as well for some languages. And of course, you can entirely switch language. So if there are any of those.
Ég heiti Dóra. Ég les upphátt allan texta sem þú skrifar hér.
Any of those 400,000 Icelandic speakers around the world will be able to understand that perfectly. So you've got quite a bit of language diversity. Even for some languages, you have pronunciation variations, which are regional dialects inside the same country. So, for example, Catalan, Spanish will be supported, or, like I said before, variations of English with particular pronunciations. So here's a male Welsh voice.
Hi, I'm Geraint. I can read any text you type here.
Which is quite a sophisticated service with plenty of voice support. Then on the SSML side of things, you'll see there's markup language which is used here to customize the pronunciation model that's used. And I've got a few examples of this that are hidden in a directory here. So if I open one of these files, let's take a look at Whisper Enhance first of all. So I can cut and paste this into the console, of course, and paste it in here. And that's one way of doing this.
When any voice is made to whisper,
the sound is slower and quieter than normal speech.
So I'm using several different tags there. I'm using the whisper tag, of course, to switch into the whispered voice for that particular customized voice. And then I'm using this prosody rate, which slows down the audio essentially to make it sound more lifelike. Okay, so I can tweak my pronunciations. And if you're doing, for example, rendering of fiction writing where you want to voice books or voice magazines or voice stories, these kinds of techniques can be really valuable for enriching the experience and making the experience more dramatic in terms of the experience that you're able to create with the system rendered voice. So one way to do that, of course, is to use the console. And then we do have SDK support as well. So what I got here? So a command which will render this using the AWS CLI looks something like this. I will make this a little bit bigger. So you can see there that I'm sending a set of attributes in the form of an API request document to our API. So I'm using the polysynthesized speech API. I'm specifying that my input text type is SSML, so it's marked up. I'm specifying a file that contains my marked up SML voice, specifying my voice ID. My output format is MP3, and I want to create a file rather than receive a stream. So if I hit that, that will send a request to the API. I'll get a confirmation document back, which is a 200 response code, together with some information about my request. The request characters are quite important because that is used for billing. Okay, so the more characters I send above a certain threshold, I'll start to generate a bill for my usage of this service. And if I was doing this at scale, I could write my own handler for the return codes that accounted for my usage, enabling me to record how much character count I'd use for different applications that I was building. So that's why that's in there. And then I can play that file.
Don't say. Ian's number is 7,917,751,800.
And that's the SSML that was used to generate the audio example that was in my PowerPoint earlier. Okay, so it's very, very simple to use. Obviously, our CLI is built on our Python SDK, but all of our major SDKs support this service. So you can use it in video games from our C++ SDK. You can use it in web apps from our browser-based JavaScript SDK, or you can use it in server-based apps using our C# SDK or one of the others that we have. So a pretty powerful service. easy to use, lots of flexibility. If you want to know more about the markup, there is comprehensive documentation for the SSML tags here on our documentation website. So you can learn more about SSML here. This is the Poly developer guide on the AWS website, and it's got a comprehensive set of docs about the different tagging options, how to control pronunciation, how to create a custom lexicon, which you can see here in managing lexicons, how to create audio files that are longer than the size that you need by using joins. All this kind of stuff is fully documented in the docs. Okay, so let's jump on and talk a little bit about the other service that I want to cover in this session, which is Rekognition. And we'll take questions on both at the end of the session. Okay, so this is, this is a similar service, okay? So it's also abstracted behind one of these AWS API endpoints. And Julian did actually give a bit of a preview of what this service is about in his demo, not with the object detection on his camera, because that was, as he mentioned, a trained model deployed down onto the Raspberry Pi, which was capable of detecting objects, but with the facial recognition, where he popped up that photograph and several people in the audience had their faces detected and identified with bounding boxes. For that particular example, his Raspberry Pi-based robot, Johnny Pi, sends the captured image to our Rekognition endpoint. It calls our facial detection API, and we send back a JSON object that contains information about faces detected in the scene. So he was using this service. It uses exactly the same access model that you use for Poly, with IAM policies, access and secret keys, and then integration with AWS SDKs and our console. Okay, so you're going to communicate with our endpoint. You're going to send it an encoded image, encoded base64 in PNG or JPEG format. Okay, and you're going to call a specific method depending on which of these options you want to use with the service. So object and scene detection, facial detection, facial analysis, face search, or a new one that we have for celebrity detection as well, which I'll show you a little bit later. And then you'll receive a JSON structure back from our API endpoint, which corresponds to the kind of request that you've made. So if you asked for object and scene detection, you'll get something back which contains all of the tags associated or detected with the image, within the image, with confidence levels. Okay? So for this example, you'd see we're 99.18% certain it's a beach. And this is quite interesting because beach is not an object in that scene. Just want to call it out, okay? Like shoreline or sea or landscape, they're not objects. Okay, they are image themes, if you want, or image characteristics. So it's more than just object detection. It is scene detection, and it can detect characteristics within the image that are non-object characteristics, like indoors, darkness, etc. Actually quite sophisticated in being able to do that. Okay, the facial detection API, we can do gender detection, we can do age detection in a range. Okay, it's not actually as specific as this. We detect in a range, so that would be 28 to 57 actually, so that needs to be modified. And then we're detecting, again, characteristics about the face. We're also able to detect facial landmarks. Okay, so corners of the mouth, nose, the eyes. Kind of useful for demos like the one my colleague Randall has, where he allows you to send an image and receive a processed image back with a mask on it. Okay, so he places the mask using the facial landmarks that are detected when you use the facial detection API. Okay, we trained the model to detect a lot of different labels. Okay, very, very comprehensive, and I'll show you that a little bit later on. We also have this facial search capability. This allows you to establish a library of faces that you wish to search and then compare your image against faces in the library. So you could use this for scene detection. So for individual identification. So a really good example of this might be something like a hotel or an airport lounge maybe. You know roughly who's likely to come during the day because you've got your guest list or you've got your list of individuals that have already booked flights on that day. So you can pull out a list of faces, maybe from the profiles that you've got for these individuals via their social media accounts. And when somebody comes into your lounge or into your hotel, you can do facial matching and you could issue a personal greeting. So, hi Ian, how are you doing today? And maybe pull out other data from your systems about that individual's travel history, that individual's likes, their profile, to deliver a personalized experience to them on the basis of their visual identity, okay, using this kind of service. Okay. This kind of technology is obviously one of the components that features in the Amazon Go store, which Julian was mentioning earlier. So part of the system is to do detection using this kind of technology as well. So you can use it to search and understand visual content. There's a question here about privacy using the service. So for full details on how data is treated, I'd advise taking a look at the AWS terms associated with this service. They're on the website, so I'm not going to answer that question here, but I'm going to suggest that you take a look at that. And if you've got specific questions about that, you should follow up with us using the Contact Us mechanism on the website as well. The pictures are private to your account and you have deletion capability, but there are some specific terms there that you should take a look at. So a console demo of Rekognition. Just jump in and show you that. I have a couple of prepared images for this, which will probably elicit like a groan when I show them, so we'll see. Also localized for the UK. Where did I put it? In common with Poly, we've got a getting started and demo experience that's entirely within the console, so you can see all of the features of the service directly within the console. Of course, like Poly, this isn't the way in which we envisage developers using the service. Developers are going to connect to this service using our SDKs and send us their base64 encoded images, probably at reasonably high volume. But this is a good mechanism just to show you some of the features. After this, I'm going to jump out and show you something that's built using the SDK so you can get a flavor of how you do that, and I'll show you some code when we get to that as well. So object and scene detection, you can see here with this sample image that we're able to detect concepts like parking, human, person, skateboard, parking lot, vehicle. So there's a lot of detail here, and the confidence levels diminish as we go down the model. So we think there's a freeway there with 50.5% certainty. Well, there's a road, but it's not quite a freeway, so we're kind of not quite sure about that one. But we are pretty sure that there is skateboard, sport, people, person, human, parking in the image, and of course there is, okay? If we want to submit an image for testing here, let me just unmaximize that. If we want to submit an image for testing here, we can just drag and drop. So let's find an image. Oh, like something like this, which is from one of our education events here in the UK. I can just drop that on here. It will be uploaded. And you're going to see here one of the restrictions of the service in a second. So this is a huge image. So the restriction that you're going to see here, I suspect is going to be on sizing, might reach the cap. So you'll see in the code that I show you later, it's necessary to resize images to be below that threshold for submission to the model. Okay, so you have to have images under a certain cap. The networking here seems particularly slow. It was much quicker when I tested this earlier. See if we've got one that's a little bit small that might have been compressed. Yeah, this one's a little bit small, and it could be interesting one to detect with as well. Let's try that. Doubt it'll be able to pull out the exact object, but let's just see what it's been trained with. Maybe it will. Do you know what these are, by the way? These are our Amazon Snowball, our 1 terabyte transportable device. So there you're looking at a petabyte of data that's about to be uploaded to AWS, actually. Yeah. Okay, So the upload takes a second, and you can see here that we've confused the model, as I thought we would. So we've got an unusual object which has not been trained on. What do you think is causing it to think there's a skylight there? These light boxes are being misinterpreted. If we go down the model, computer, LCD screen, PC, electronics, vehicle, SUV, car. So we've got low confidence on this image because it's quite an unusual image that we've probably not had a lot of training data on. Yeah?
Can you train specific models?
So the question is, can you train specific models? And the answer is no, not at this time, no. At this time, you've got a shared space, which is a shared model, which is public, essentially.
Is it in development?
Can't talk about roadmap items, but I can say that it's a very common request from customers to have the capability to train specific variants of the model for specific use cases. I've heard it from a lot of customers. I actually heard it from customers in the industrial sector that want to do things like recognize parts of vehicles or recognize particular components in, say, the aerospace industry. So I think there's definitely demand for it, but I don't know where it is on the roadmap, actually. So that's what you can do with Rekognition. Of course, we've got sample images with object and scene detection. Of course, we've got other sample images as well. Image moderation. So this is a newer feature, and this allows you to do safe content detection. So looking at this image here, it's suggestive, it's female swimwear or underwear, and we have categories here. So if I jump back onto this other image, you'll see the metadata that we get for this is no moderation labels detected, which means it's a piece of content that is regarded as entirely safe. So there's no risk associated with that content of causing offense to anyone. This one is scored as suggestive with 83.5%, and you can see it's a woman on the beach doing yoga. So we've got other gradings significantly worse than that, let's say. So if you are running something that requires content moderation, you can triage your content for moderation and allow that content to be reviewed by humans before it gets posted, or even discard content that breaches a certain threshold. So you have quite a lot of flexibility there. Facial analysis. This is what we showed you before. Looks like a face, appears to be female. Actually, it's very accurate. And it'll also do this landmark detection. So in this one, we're going to have multiple results back because we've got multiple people there. So you can actually evaluate multiple humans in the same image. This all comes back in one response document from the API. So you'll get a very long structure if you've got a lot of people in your image, which calls out their face location with the bounding box capability, or rather with the coordinates where you could draw a bounding box. It will put those landmarks on. All this will be embedded within the data structure, which I'll show you a little bit later. Then celebrity recognition. I'm going to use our localized demo here. What have I got left? Okay. So for the demo that I did, okay, let's get some local celebs. Okay, it's Theresa May, 100% confidence. So that's pretty accurate. And then over here, we've got Corbyn, also 100% match. So we've got politicians, sports people, business leaders. There's quite a deep collection of faces, and it extends into quite a few different geographies as well. This is the kind of functionality that the C-SPAN use case uses to detect those US political figures in the video archive that they have. They have around about 100,000 different people involved in politics in Washington that they've indexed using the service. So we have 100,000 US political figures in the system, a large number. And we have lots and lots of depth in other geographies, other countries around the world for celebrity, political, other notable public figures that are recognized by the service. We could do that facial analysis actually on one of these images as well, just to show you that does work with images outside of the demo. In the console, and also show you that it does work well with very small images. That's a very small image. It's 7 kilobytes in size, so there's not a lot of pixels. That's the actual size of the image. It's not being compressed to fit in that box because it's smaller than the box. And you can see that we get that image metadata back there. So Theresa May does not have a beard, can confirm, 98.4%. Okay, and then the other thing that we have is this facial comparison, and I'm sure you'll be delighted to know that I've got 2 pictures of Theresa here that I can use for that. So we can match. She's not in that picture, obviously, so that's our control reference, and this is our comparison. Obviously, she's not in there, but if I get this other image, which you can see is a different shot, and her face is significantly smaller in this second image, which in itself is not a large image either, you'll see that we've got a 98% match there, and this is how effective this facial matching component of the service is. Okay, so that is Amazon Rekognition. Next thing that I wanted to do is just quickly show you another demo which combines both console and, combines the 2 services together, and it uses one of our SDKs to do so. Like any demo that involves a lot of code, I'm going to quickly skim through this and just show you how it works at a high level by trying to point at relevant code blocks in an editor. But if you do want to grab the demo, you can find it on my GitHub here, clone it. You need a camera, you need a Mac. It's tested with CV2 on the Mac, so you need CV2 installed on your Mac, which is not easy, but is possible to do if you follow some instructions that are available on the web. Build the Python bindings for CV2, and then you can run this yourself and see it working. Okay, I'll distribute these slides on my Twitter and SlideShare later on today. Okay, so the code that I've got here, there's one thing to say about using cameras on the Mac, which is that CV2 does not warm up the camera gracefully on the Mac. So if you are going to use a camera on a Mac for image capture with CV2, you need to warm up the camera using another application to get the camera active before you try and make a capture. So that's why I've got Photo Booth running. It also allows me to position the camera live so I can see what I'm going to be pointing at and make sure that I get a good image. On the code, let's just make this a bit bigger. What I've done here is combined Rekognition and Poly together. So I'm going to use voice generation, dynamic voice generation, to read back what has been detected by the scene detection and facial recognition methods on the API that we have. So you'll be able to see that I'm able to generate dynamic speech. I take a picture, or I can read a file, okay? And then I send that picture off to our API for detect labels, which you can see here, this little function. I'll get something back. Okay, I then evaluate the response that I get, and if there are faces in the image, I send the image off again to our detect faces API. Okay, and then I receive a response back from that, and I render that response verbally using Poly by sending off selected attributes from the response to the speech API in a constructed sentence. So using some English validation routines from this module here called inflect, to make sure that I transform the response from the API into the right format by adding plurals and making sure that the right adverbs and stuff are present in the overall response to make it English. Okay, so I'm using some automation for that as well. And if I run this, let's just pull the camera to the front as well. There's a question on the stream about whether you can train people into the system globally or per account. So the celebrity detection is trained in globally. To answer you, Phil Price, the celebrity detection is trained in globally. In the per account case, it would be a case of building a matching set. So you'd have your matching set of images within your own account that you would then compare, matching set of faces in your own account that you would then compare your test images against. And that matching set is something that you can configure and maintain within your individual account, to answer your question. So yeah, let's run our capture.py. There's some audio again here, so guys upstairs, just make sure people can hear my audio.
Please point your external webcam at the subject. Taking a photo. I detected the following labels: person, human, audience, and crowd. I can see 15 faces. The first person is male. He is wearing spectacles. He is not smiling. He looks happy. The second person is male. He is wearing spectacles. He is not smiling. He looks sad. The third person is male. He is wearing glasses.
And so we'll
He
go
is
on.
not
What I've done
smiling.
there is cap
He looks
the
confused.
number of
The
faces
fourth
that I'm
person
going to
is
render
male.
the audio for
He is
down
not
to
smiling. He looks happy.
5, but
The
obviously
fifth
more
person
faces was
is male.
detected.
He
There's
is
actually a
smiling.
limit of
He looks happy.
12 faces per scene right now for detection. So if you did have a large scene and you want to detect more faces, you'd have to use a technique like putting a black box on all of those faces and then resubmitting the request. And by doing that, you could cycle through and detect additional faces, but you'd require multiple API calls to do that today. So that is a quick introduction to Rekognition and Poly with a quick run through of some features in the console for developers that want to test and experiment with these services to familiarize themselves with them, and also a quick code sample plus a demo of the service being run by the service is being used by an application that uses our Python SDK. So hope that's been an interesting intro. Does anybody have any questions in the room? Yeah.
So in this last demo, when Polly was reading out who she recognized,
Yep.
what order was she doing the faces in? Was it the size of the binding box or the order of the person?
So the question is about how ordering is determined for the faces. It's not something that I've experimented with, okay, but I think that it's to do with relative size. If you were to take a look at that image, you'll see that the read-through is on the basis of how big the face bounding box is, okay? So I'm pretty sure that the way in which the response is ordered is on the basis of, hang on, I want preview, is on the basis of the size of the boxes, but I'd need to experiment with that a little bit more. It kind of went to this gentleman down here, and then this gentleman in the second row, which you can see in red on the screen, and then I think it would go to the blue next in the center, purple and white, okay? So it seems to be to do with size, relative size of the faces, but I want to test that just to make sure that's the case. Yeah. You could actually sort them, of course, because when we get the API response back, which you can see here, okay, we're going to get our bounding boxes back. And when we receive our bounding boxes, we could actually definitively sort the faces by bounding box size in our code. Okay, so if we wanted to fix the size, the sequencing, it would be possible to do that programmatically, just to program defensively against any ordering change there.
So then you can probably order according to who's wearing glasses and who's...
Yeah, of course, yeah. Yeah. So this would come back, we're loading that into an object in the case of Python, but into a data structure depending on what programming language we're using. And then once we have that in our code in memory, we can manipulate it as we wish, of course. Yeah.
I've got a second question. On the beach photograph,
Yeah.
there was it seemed like it was like a statistical co-occurrence with the hotel, because it said there was a hotel, it was like 51.24.
Yeah.
So is that because the existing data set, there's a hotel next to the beach, and so it's kind of...
Which one were we talking about?
The beach with the palm tree.
Yeah.
It's like the first...
Was that on the top page maybe? Hang on a second, let me go to here. Oh, it was on the slides, wasn't it? Yeah, sorry, yeah. The slide is a demonstration image, so I don't actually know whether or not those results are results that have come back from the API. It's likely that someone's just put those results in for illustrative purposes. So what I would want to do really would be to resubmit that image to the API and test it. So maybe we should do that now and just check what we get back, yeah? Shall we? Yeah, let's do that. So let me quickly capture that image as a screenshot. Okay, let's export that. It's going to work, yeah. Pop that on my desktop. And then let's find that file and we'll drag it in there and get it evaluated, beachhotel.png. Okay. Yeah, so hotel is not present there. And this is an interesting attribute. I'll tell you a story here, which is an interesting attribute of the service. I might have another image which can just help me demonstrate this, or at least I hope I do. There it is, image1.png. Yeah. This is a really interesting example of probably this effect. So this is my back garden, okay? Before I had it landscaped, so it now looks better than that, first thing I want to say. Okay, this is just after I moved into my house, or shortly after I moved into my house. I don't see a castle there, and I don't see a fort or a moat either, okay? It would be nice to live in a castle, but unfortunately I do not live in a castle. So what happened when I first submitted that image is backyard and yard didn't feature. Okay, they weren't actually in the returned data structure from evaluating that image. So I sent this image over to our research team that are responsible for the models for Rekognition, and they said, try now, a few hours later. And I tried, and yes, they'd amended the training data, and now, yeah, it does think that there's a castle and a ditch and a fort and a moat there, and if you look at the image, you can understand why, but it's also, in quotes, learnt that there's a backyard or a garden there. Okay, for you English, of course, British, a garden, rather than the backyard. So this is one of the benefits of using this kind of service rather than training your own model. As the models improve over time, the accuracy of your applications will also improve in line with that. And I suspect with beach or hotel, you're seeing the same thing. Maybe that did used to return the fact that there was a hotel there, and it's being raised as a training anomaly, and then the training data has been rerun, or the model's been amended to reflect improvement on that issue and remove the anomaly from the return data. Okay, so yeah, no castle, but castles are made out of that kind of stone, so you can see why you could confuse the model. Yeah.
Is it possible to give feedback on the correct information? For example, if it says phase 1 is person A, and to some way I can say that it's not person A, it's person B.
If you see anomalies like that, you should contact us. So you can contact us via your solutions architect, or use the contact us form on the website, and you can submit the anomalies, maybe provide us with some URLs for where the anomaly occurs if you're able to illustrate it. That feedback will reach our research team, and we can then improve the model. So we'd love to get feedback from customers about this service, yeah, definitely. Okay, any other questions? Okay, so Brownetti on stream asks about the possible future of searching for images. So one of the most common use cases for this service is creating metadata repositories that are associated with images. Okay, so customers already use the service in that way. It's just that what they do is when they receive the images that they want to index, they submit them to the Rekognition API, they receive back the structure which contains the evaluation, they're storing that in a non-relational or relational database, depending on what the data model is that they want to use. And then they can search that relational database and find a reference, search that database, regardless of type, and find a reference to the image. We've got a customer, for example, in the Netherlands called Binder, who are in the content management business. Binder, these guys. They're in the content management business, and one of the ways in which they use Amazon Rekognition is for index and search of images, so digital asset management. They're receiving images on behalf of their customers, they catalog them, and then they make it possible for you to search those images without a human being being involved in that process. So that's a super common use case. What is the preferred way to feedback training on mode anomalies? As I just mentioned, to use the contact us form on the website, or contact your AWS account manager. Everyone has an account manager, by the way, and a solutions architect allocated to them. So if you use that form, you can actually get the contact details back for your nominated people, and they can help take the feedback and make sure that it reaches the right person at AWS. How much cost to modify the DB model? Well, as I just described, storing that metadata would be outside the Rekognition service. So you would run your own relational or non-relational database using either one of our services, or using a build-it-yourself approach, depending on what your preferred technology was. A lot of customers obviously use our service DynamoDB for that. Actually, the AWS Elasticsearch service is also a good target to use for storing and indexing image metadata, because of course it's naturally searchable and it has dashboarding and a really well-used and well-understood API as well. So it's quite common to store this indexing data inside something like Elasticsearch. Okay, I think we're just about out of time. Yeah, I'm being told to cut. So thanks for joining this session. I'll be back at 1 p.m. with Amazon Lex building chatbots on AWS. Just one final thing for the audience that are here. We have a Pitch Your Project event today, so if you want to head outside, we are listening to customers' ideas for building new services and products using AWS, and the best pitchers will win AWS Activate credits. So if you do have a business idea that you're here to explore today, please chat with our team. There are prizes up for grabs. Thank you.